roads between them. Unfortunately, the condition of the road is so poor that they cannot be used. Your task is to repair some of the roads so that there will be a decent route between it two cities. Roads are so poor that they cannot be used. Okay, that means no road is currently being used, and we need to prepare some of the roads to make this city connected so that there is a route between any two cities. For the road, there is a cost, and you should find the solution where the total cost is MST. Minimum spanning tree we need to find. It seems all the roads are two-way roads. Okay, I think fine. Let's try run over this example. So from 1 to 2 there is a cost 3. From 2 to 3 it is 5. From 2 to 4 from 2 to 4 there is cost of 2. From 3 to 4 cost is 8. From 5 to 1 cost is 7. From 5 to 4 cost is 4. If I need to find the MST, let's pick the smallest edge. Can I repair this? Yeah, we can repair this. So 2 to 4 cost is 2. Can I repair this edge? Yeah, we can. Cost is 3. Can I repair this edge? Yeah, cost is 4. Should I repair 7? No, because it is already connected. Can I repair 5? No. 5, yes, we can. So total cost is 2 plus 3 plus 4 plus 5. 5, 5, 10, 14. Is it the 14? Yep. I think we need to write the MST code only. So DSU. Okay. How to write the DSU? I think we'll have to maintain. That's right. So void unite union find unite two nodes u and v and union and find the parent of find the parent of node u. Okay, we need to have the vector. What is the parent? What is the parent of each node? Let's say it is -1 initially. Every node's parent, and we also need to find, so we can do the path comparison here, and we need to rank. We need the rank also. So every node's rank is 1 initially because size is 1. So it will be used for path comparison and it is for the rank. Now we need to find the parent of node u. Let's read the input. Adjacency of vector of. Do we need this or edges? We need the edges now. So we have edge from A to B of weight of some weight. Okay, let's have a vector only. Vector of edge, 3 value 0 1 2. That means edge dot push back a vector So we have m edges. Let's read all the edges. What is the weight? xy, x to y, there is an edge. That means edge dot implies back. We can say from x to y, there is an edge from x to y with the weight z. Shall we sort it? Let's write z here, x and y here, so that once we sort it, it will be sorted according to its weight, the edges. Okay, without using comparator. Edge dot end. So we sorted it. Go to each edge, make it edges. Edges, edges, edges for each edge. Over the edges, so we have the weight x and y. So there is a path and y is edge of 2, and what is the cost? It's nothing but edge of 0. So can we how to find the parent of u? So how can we combine x and y, the edge between x and y, if and only if they are not belonging to the same component, right? They don't belong to same group. That means their parents must be different. So find parent of x is not equal to find parent of y. If the parents are not equal, then we can say answer plus is equal to cost, and we need to unite these two, x and y, these two nodes. We need to put them in our MST. Finally print the answer. Okay. So go to every edge, x, y and c. If they don't belong to same group, then unite them. Right, they don't belong to same group, then unite them, and answer plus equal to c. Okay, let's write how to find the parent of u. With path compression, can return the parent of u. Let's mark it as we'll save it also. If parent of u is equal to u itself, means parent of u is equal to u itself, we can return u. Otherwise, if it is not u, we can say we find me the parent of u. Find me the parent of, find the parent of, so the parent of u, now it will become the parent of u only if it is. So if 1 is my node and 1's parent is 2, 2's parent is 3. So ideally, if we want to find the parent of 1, so we check whether the parent of 1 is equal to 1. No, it is not. So it will find what is the parent of 1. Current parent of 1 is 2. What is the parent of 2? It will find 3. So parent of 1 becomes 3. And for 3, it will be the base case. I think, yeah, it works. And how to unite them? So let's find the parents. So let's parent or set of 1 is the parent of u, and set 2 is the parent of v. So if s1 is equal to s2, we can just return. If they belong to same set, we return. Otherwise, we need to, I think here, let's make for eta is equal to 1, let's make every node as, you can say parent of I is I only. We already have defined rank as 1. Okay, every node's parent is itself only, and go here, then find if they are not belong to same set. That means I can make the parent, I can make them parent. Now let's see if the rank of s1 is less than rank of s2. S1 is smaller than S2, then that means S1 should be attached to S2. That means the parent of S1 should become S2. Parent of S1 should become S2, and rank of S2, since S2 becomes parent, so rank of S2 will increment by the rank of S1. Is it correct, or let's otherwise the reverse case? So it will be the parent of S2 will become S1, and rank of S1 will increment by S2, rank of S2. So we find the parents, not this one, otherwise it will be wrong. We find the latest parent. Okay, so what is the parent of u? What is the parent of u? What is the parent of v? If they are equal, we don't need to unite them. Otherwise, if the rank of s1 is smaller than the rank of s2, that means s2 is larger, we can attach s1 to the s2. So parent of s1 becomes s2, and rank of s2 gets incremented. If s1 is greater, then s1 becomes parent, and s1 becomes parent, and its rank increases. Is it all okay? I think yeah. So we read the nm, go to every edge xyz, and take the edge in place back with the z as first element, sort it according to their edges. Now take the minimum, so every parents, go to all the edges. If they don't belong to same set, then only unite them and increment our answer by that cost. Okay, so does it through? No, it will not. But cost can be 10 raised to 9. I think it will be LL. Answer plus is equal to C. And how to unite these two? U and V, find their sets, and if they belong to same set, otherwise rank and parent will also change. Next time if you find the parent, how to find the parent of U? If U itself is its parent, then that means the parent is U. Okay, otherwise we need to find the parent U's recursively, and we also do the DP, so it will become path compression. It should work. Okay, what is this? I think rank is already a reserved keyword. it's still not. Find was not declared in the scope. Okay, it needs to define here. $17.47. What is this? 18. Invalid comparison from int 21. Conversion from int star to int. Okay, why it is complaining? Acha. No, it is not able to create this value. What about pushback? It's working, I think. Segmentation fault. It is going infinitely. Why would it go vector vector int edges, parent and rank? Find the parent of u. It should be this one now. Is equal to u. This. It was 14. We have taken LL. It should be fine. Okay. What? Bad. So it is impossible also sometimes. We had to print that. I haven't handled that case. When is it impossible? When the root, when this graph is disconnected. Just one road between two cities. Just one road between. Every road is between two different cities, and there is at most one road between two cities. At most one road between two cities. Yeah, Palliage. And self loop is not there. Print impossible if and only if. When is it impossible? It is impossible only when there is more. Only when there is a forest. There are different components initially. I think that we can solve. Just run a DFS. But can we do it with the union find only? Okay, finally, once everything is done. then I think there should be only one component, right? So everything is attached. So is like every node's parent is should be a single node. Then only they are in the same component. In the final case, if it is not the case, okay, so what is the parent? So I think I got it directly. What is the parent of? We can call super parent. The parent of every parent, the parent of every node. We can, let's say, super parent of 1. Then for each of the nodes, what is this? For each of the nodes, let's find the parent of that node. Okay, and we can say what is the parent of this node, and we can say okay, this super parent. So if we can directly write here, if super parent parent of I is not the super parent, that means answer is impossible. Answer is impossibly. Okay, so if it is not the case, so any node's parent is not the super parent, then it is impossible. Otherwise we can return from here only. After printing impossible, otherwise see out that answer every node's parent is the same parent. Yeah, I think this should work. Let's see. If it doesn't work, then DFS is the savior. Yeah, worked. It's easy. Rank and the parent using the path compression, and this is the rank. Okay, and how to this creation does not work with in place back, it works with the pushback only. Okay.